chemical reactions are a lot. There are a lot of things that will happen when it comes to chemical reactions. We say chemical reactions, um, products, or yes, reactants, substances come together called reactants, right? They react, undergo some manipulation, rearrangement, and then they form products. That's what we say. But then we need to know that when based on the reactants that we have and under some conditions, they are expected to give us some products, right? There are some reactions that when they come together, we are expecting them to form some product. So once you are able to identify the reactants, what components are coming together as reactants, and whatever transformation they need to undergo, and the conditions are similar, what happens is that you, as a chemistry student, you need to know the expected outcome, the expected product. So common reactions, you need to know them. So I'm not expecting that you know all of them at once, but then when you are getting familiar with them, it's very necessary that you get familiar with them, right? And then as you practice it more of time, then you get used to it. That's how it comes with experience and with practice. Let's look at these common reactions that we are referring to. So the very first one will be knowing that acids react with bases to form salt and water. When you have an acid and reacting with a base, they are going to form salt and water. So I'm going to give a simple example. The simplest example is HCl plus sodium hydroxide, and that's going to give us a salt, NaCl, and water. So you are expected to see some water. This is water. This is a salt, right? Sodium chloride is a salt, right? So basically, a metal mixing with an anion, right? A compound of this thing, such that the anion is not hydrogen, right? Mostly, we call them salts. So these are salts, right? Yeah. Um, this is a base. So the base have this anion component that we mentioned them before in one of our series when we were doing a UPAC nomenclature, that these ones are specific, right? We call them hydroxide ions. They have the hydroxide ions in them, right? So that's what happens. So what happens in them is that this hydrogen from here combined with the HO from here, that's what will combine to form the water, and then the NaCl is because of this and this coming together to form the NaCl. That's why we say chemical reaction is just basically rearrangement of what atoms, rearrangement of atoms to form a particular output. That's what we have. So there has been rearrangement, and the NaCl is coming as a source, and the water is also coming as another product, right? Yeah. So you have to know that acids, especially strong acids, we have a strong basis to form salt and water, salt or water. Acids react with bases to form salt and water. So when you're able to see an acid and a salt, an acid and a base coming together, your output should be water and a salt. So you know that H2O always come out, but then you do their rearrangement, knowing that which kind of salt is there, which kind of salt is there. Assuming this one, instead of sodium, we're having something like uh, potassium here, then it will not be Na here, it will now be K. It will not be K. But we know that water will always be formed. Water will also write water, then you combine the rest to form the salt. Let's look at another reaction. Acid reacts with carbonate to form salt, water, and carbon dioxide. So I'm going to use another example again. If you have an acid and you have the carbonate that I'm having here is Na2CO3. This is a sort of carbonate. This is a source of carbonate. This is a sort of carbonate. CO3 2 minus, right? But then any metal combined to give you a sort of carbonate, right? This is a sort of carbonate. So we don't care whatever is here, but then this guy should be a metal, right? A metal type 1, mostly metal type 2. Then you combine it with a CO3. There is basically the product you are supposed to get is a salt, and the salt in this case will be NaCl, right? So you see that Na and Cl from here plus water will come, and you have to know that carbon dioxide will also follow. Then we'll balance these things out throughout and stuff, right? And this is already balanced, but we'll talk about balancing of reactions in the continuing sessions, right? There are things we are doing step by step, so take your time. Yeah, so we know that an acid, once you see an acid and a sort of carbonate, when you see a sort of carbonate, you know, okay, water and carbon dioxide should be the outcome. Those are the things that you need to know. Then the salt, you basically work out the salt based on the kind of carbonate and acid that you have. But you know that H2O and CO2 will always be the output. Then you write the rest. These are the reactions that you need to know. Basically, you need to know that. So know the output. Hey, I'm having an acid and I'm having a sort of carbonate. We're supposed to give you carbon dioxide and water. So that's the outcome that you want. As you get familiar with them, you get to know them. Another one is acid reactive sort of bicarbonate. So sort of bicarbonate is similar to what we did so far. So like ACl plus. So the bicarbonate is actually this one, NaHCO3. So we were having Na2CO3, right? But here NaHCO3, the H is introduced. It's also going to give you the same thing, right? It's going to give you NaCl, it's going to give you water, and it's going to give you carbon dioxide. So the carbon dioxide and H2O are constant, and then the salt, depending on whatever compound they have given you, then you just do the rearrangement. There's another one again. Acids react with salts. Acids react with salts. Salt of sulfite. Sulfite. So let me do ACl plus Na2SO3. SO3 as a source of sulfite to form. So we are going to form a salt over here again. The salt we are going to NaCl again because the Na from here is combining with the Cl from here. Then we are going to form water, H2O. Instead of carbon dioxide, we don't have C here, we don't have, so we are going to have SO2. Instead of having CO2, we just have SO2 because it's a source of sulfite. That's something that you need to actually know again. So instead of having CO3, we are having SO3. So we have CO3 previously, but this one have SO3. So it gets salt and CO2. So instead of having CO2 here, we have SO3. So know that basically. Let's do another example. Acid we have is sort of sulfides. Sort of sulfide. So let's say we have acid again, and then Na2S sulfide, not T at the previous one, sulfide. Then we are going to have water. We are going to have water. We are going to have the salt. The salt here in this case is going to be NaCl, and then hydrogen sulfide, that's H2S. Hydrogen sulfide. This is what we have in this section as well, right? So we have a sort of sulfide. We are going to form water, and this, and the salt, and the salt. The salt can vary. That's why we just say salt. So all those plenty things, combination of metal and non-metal, right? That's going to give you a salt generally. So when you were able to get the constant product like water and the H2S, then you just use the rest to form the salt out of that by through rearrangement of simple atoms. Let's do another one. Metals react with oxygen to form metal oxide. So if I have zinc and I'm adding oxygen to it, this is going to form zinc oxide. So zinc oxide, the metal oxide, so zinc oxide. The same way, if I had sodium here and I'm adding magnesium to it, it's going to basically form Na2O. So basically this is what it's going to form, right? It's going to form sodium oxide. Sodium oxide. If it were magnesium, your magnesium reacting with oxygen, then it's going to have MgO, magnesium oxide. Basically that's how. So metals react with oxygen. So when you see a metal reacting with oxygen, they are going to form metal oxide. So the metal has the zinc oxide and all that, right? That's another simple example. So know these examples as well. Another example that I need to know: metals react with acids to form salt and hydrogen gas. So let's say we have HCl, and then we have a metal. So metal reacting with an acid is going to form a salt, ZnCl, right? And this is how you get hydrogen gas produced. If you want to produce hydrogen gas, this is one simple way, right? HCl as an example, then zinc. So HCl is an acid. It's an acid. So we've done that when we're naming IUPAC nomenclature, how to name naming of acid, binary acid, and all that. We've taken care of them all, right? It's under our series of IUPAC nomenclature of inorganic substances. So we know that this is an acid, hydrogen chloride combined with zinc. It's going to give you a salt and hydrogen gas. Basically, that's another one. So no, metals react with acid to form salt and hydrogen gas. So you get familiar with this as time goes on. So once you know that acid is reacting with a metal, I'm supposed to have hydrogen gas and a salt. So you get familiar with that. It doesn't, when you practice, you don't have to chew it later on. You have hydrocarbons reacting with oxygen to form carbon dioxide and water. Hydrocarbons are these organic substances that have only carbon and hydrogen only. For example, I can give CH4, right? And then if they are reacting with oxygen, then it's going to give you water and carbon dioxide. So when you have a hydrocarbon where there's only carbon and hydrogen alone, that's what we call hydrocarbons. Carbon and hydrogen alone, that's what we call hydrocarbon. Reacting with oxygen, they are going to give you water and carbon dioxide. this is also a simple one. Carbon and carbon dioxide are always the output, so you need to know those ones as well. Yeah, as simple as that. So yeah, know about this, the outputs. This is know about these metals reacting, and like you need to know these samples, and then you are good to go as a chemistry student. You know these common ones because you'll be meeting them in some of the reactions, and they will ask you to balance them, knowing that, hoping that you know this common one at least, right? Yes. Let's see how it goes. We continue with the next concept in concerning chemical reactions. See you in the next session.